Okay, now we're going to do 2008 question number 6. This is also a no calculator problem. Okay, let f be the function given by f of x equals natural log of x for all x is greater than 0. The derivative of f is given by f prime of x equals 1 minus natural log of x all over x squared. Could have easily found that in the game to make it a little easier. So A, write an equation for the line tangent to the graph of f at x equals b squared. Okay, so whenever I see the line tangent to the graph, that means I need to find the slope. So I need to find f prime. Luckily, we're already given that f prime of x equals 1 minus natural log of x all over x squared. So when I'm finding f prime evaluated at e squared, that's going to be my slope of the tangent line at that point. So I have 1 minus natural log of e squared all over e squared squared. So this is 1 minus, the 2 can go to the front, and then I have natural log of e, which we know natural log of e, like they cancel, it becomes 1 all over e to the 4th. So 1 minus 2 is -1, so -1 all over e to the 4th. That's my slope. Now this is at the point with x value of e squared, but we don't know what the y value is, so we need to find the y value. So my y value at x equals e squared is natural log of e squared all over e squared. So 2 goes to the front, natural log of e cancels, so it's 2 over e squared. Okay, so that means my point is e squared almost 2 over e squared. So I'm going to use that point in my slope to find my equation of tangent line. So y minus y1, so 2 over e squared equals m, and negative 1 over e to the 4th, x minus x1 squared. That's how you do that. So leave your answer like this. If you tried to make any simplifications and you messed up, then you would get your answer wrong. So I would leave that always like that. Part B says find the x coordinate of the critical point of that. Determine whether this point is relative minimum or maximum or neither for the function. So critical points occur when f prime of x equals 0. So 0 equals 1 minus natural log of x all over x squared. Now, we also have to consider when the denominator is equal to 0. So the first one is when x is equal to 0. That's a critical point. The other one, let's try to solve 1 minus natural log of x. And get natural log of x equals 1. So remember, natural log is log base e, so it's log base e of x equals 1, so e is 1 equals x. So that x equals e. So we have 0 and e. Now we were given that x is greater than or equal to 0 anyway. So that's not actually a critical point because it's not a number. So we're testing an f prime. When I test a number less than e is about 2.7. So let's try 1. Test it in the original. Natural log of 1 all over 1. Oh, not in the original. Check it in your f prime. So if I plug in 1 here, I get 1 minus natural log of 1 all over 1 squared. 1 minus natural log of 1, that's 1 minus 0. So 1 over 1 is 1. So it's positive. Anything on the right of e, so like 3, they have 1 minus natural log of 3 all over 3 squared. This is a no calculator problem, so it's kind of hard. You may not know natural log of 3 in your head. But natural log of 3, it is bigger than natural log of e. The natural log is like this. So natural log of e is 1. So it's 1 minus something bigger than 1, so it's going to be a negative. That means I was increasing and then decreasing. So that point is a relative maximum. Now, when the AP readers read this, they do not look at this chart at all, so you need to write out the explanation of why that's a relative max. So let's go ahead and say that. So let's say f prime is positive from 0 to e and negative on e to infinity. You could also say f is increasing on 0 e and decreasing on e to infinity. So there is an absolute max or relative max at x equals e. That's all we need. Right, part C says the graph of the function f has exactly one point of inflection. Find the x-coordinate of this point. Okay, so points of inflection, those are going to occur when you go from second derivatives positive, second derivatives negative, or vice versa. So let's look back at that. So our first derivative is 1 minus natural log of x all over x squared. We need to find the second derivative. So we say low d high minus high d low all over the square plus below. So low d high, so d low minus derivative of natural log of 1 over x minus high d low is 2x all over the square plus below, so that becomes x to the 4th. So x squared times 0 is 0, x squared times 1 over x is negative x minus, multiply your 2x in as you do this. So 2x times 1, 2x, and then this is going to be plus 2x natural log of x, plus x to the 4th. Okay, negative x minus 2x negative 3x plus 2x natural log of x, x to the 4th. You can pull out an x from everything, so I get negative 3 plus 2 natural log of x all of x to the 4th. Okay, we need to find the places where x double prime is equal to 0 or it's undefined. So the first place is at 0, but yet again that's not in our domain, so that doesn't matter. So I'm finding when negative 3 plus 2 natural log of x equals 0. That's the numerator. So add the 3, divide by 2. Natural log is log base e, if you need to rewrite it as e. So it's going to be e to the 3 over 2 equals that. And that's a little bit bigger than e to the first power, like e to the 1.5. So we can test a number between 0 and e to the 3 over 2, so 1. If I test 1 and f double prime, I get negative 3 plus 2 times natural log of 1, which is 0, all over 1. So that's a negative number. I test a number bigger. So so let's try e squared. That would be bigger than e to the 1.5. So let's do negative 3 plus 2 natural log of e squared all over e squared to the 4th. Natural log of e squared, the 2 goes to the front and becomes 4. Natural log of e is 1. You have positive on top, positive on bottom, so it's positive. So it's concave down and concave up. So there is a point of inflection at e to the 3 over 2. But yet again, they don't look at this line chart that we've made. So you have to actually write out why that happens. So we're going to say that f double prime is negative on 0 to e to the 3 over 2 and positive on e to the 3 over 2 to infinity. So there is a point of inflection at f equals e to the 3 over 2. Now notice they didn't actually ask for the actual point, they just said find the x-coordinate of the point of inflection. That's all you need. All right, and then part D, that's a very simple one. It just says find the limit as x goes to 0 from the right of f of x. So limit as x goes to 0 from the right of f of x. So looking back at what we've done before, we said f prime was undefined over here, and that makes sense because f of x is undefined when you plug in a negative. We can't have x equaling less than 0. And then it's positive, so it's increasing and then decreasing. Okay. What's happening, I think I really need that. Let's look for natural log of x over x squared. So this is one that has x goes to 0 from positive and natural log of x squared. If I plug in 0, natural log of 0 is undefined. If I plug in 0 on the bottom, you can't have a 0 on the top. So if you tried values that were getting closer and closer to 0, the natural log of numbers that are really, really, really small is actually getting closer and closer to negative infinity, which is kind of hard to see. That's what we were talking about, with increasing until it gets to that point and then it's decreasing, like you saw from our f graph. So this is actually going to negative infinity. Okay. So that is the end of our question. Let's talk about the points for each one. For part A, you get 1 point for finding f of e squared and 1 point for finding f of e squared. Or at least, yeah, so 1 point for this value that we found, the y value, and 1 point for finding the slope. So we got our 2 points. Part B, we got 1 point for realizing it was at x equals e, 1 point for realizing that it was a relative maximum, or absolute maximum in that case, and 1 point for the justification, so saying that f is positive and negative. All right, and the last one we get 1 point for our answer, which is negative. All right.